Assalamu alaikum everyone, I hope you guys are doing well. So in this video has been a long time coming. I did a stream earlier where I covered all the concepts related to permutations, combinations. In this video, there's one concept which I didn't cover during the live stream, and that was basically how to solve questions where you have to work out NCR and NPR without a calculator. So as you guys hopefully by now are aware that there has been a change in paper pattern in Add Maths, and now you have a paper in which you're not supposed to use a calculator. So that is where you can most likely expect questions like these, where you're not supposed to use a calculator. And frankly speaking, even if you wanted to use a calculator in questions like these, you still won't be able to, because the questions are designed in such a way. Now, NCR without a calculator is something that is also tested in binomial, because in binomial also we use NCR to expand. And we use this when the power of the binomial is not given. So although I covered that part of the concept in binomial, but I'm still going to go over it so that it's revision so that you guys can also revise it alongside. So basically what we're going to do is we're going to first come up with some standard rules. Now, one thing that I'm assuming is that you guys know the concept of permutation combination very well. Okay, so the prerequisite of this is that you're well aware of permutations and combinations. Now, 5C0, if you work it out, use your calculator, because we're trying to identify a trend over here. You'll notice that you get 1. Similarly, if you use your calculator to work out 10C0, you will once again notice that you get 1. And similarly, if you work out 11C0, you will notice that you get 1. So the trend here is that if after C you have 0, then no matter what is the number before C, the answer is ultimately going to be 1, which means NC0 is equal to what? NC0 is also equal to 1. Okay? Now, if you work out 5C1, so go ahead, use your calculator. You'll notice that you get 5. If you work out 10C1, you'll notice that you get 10. If you work out 11C1, you'll notice that you get 11, which means that if you work out NC1, you will get n. No matter what the value of n is, you will get n. Similarly, if you work out 5C5, you will get 1. If you work out, let's say, 10C10, you will get 1. If you work out 11C11, you will get 1. And if you work out NCN, you will get 1. So this basically means that how many ways can you select 0 objects from 5? There's only one way. How many ways can you select 1 object from 5? There are 5 ways. How many ways can you select 5 objects from 5 objects? Once again, there's just one way that you can do that. Okay, so that's why these are your standard rules. Okay, so these are your standard rules. There's no need to expand over here. This is it. If it's NC0 or NC1 or NCN, there's no need to expand. You can just straight away give the answer. Okay, now, before we solve this question, there's something else that we need to learn. And what's that? Here it is. So if you want to expand NCR without a calculator, I want you to once again identify a trend. Okay, so I'm going to work out a few expansions, and your task is to identify a certain trend. So if let's say it's N7C2, the way that we work this out is it's going to be 7 times 6 divided by 2 factorial, which basically means 2 times 1. So 7 times 6 upon 2 factorial, which is 2 into 1. If let's say you work out 10C3, or the way to work out 10C3 is 10 into 9 into 8 divided by 3 factorial. Okay, so your task here is to identify a trend. And if let's say you work out 15C4, you will notice that you get 15 into 14 into 13 into 12 divided by 4 factorial. So hopefully you have identified a trend. If not, let's do another example. Let's say it's 5C3. That would be 5 into 4 into 3 divided by 3 factorial. Now, what's the trend? Hopefully you've identified. The trend here is this, that in the numerator, you have the same number of terms as R, okay, starting with n, and every following term is 1 less than n. So that means if you start with 7, the next term is going to be 1 less than 7. And then the term after that, 1 less than that. But if it's 7C2, so you'll have 2 terms in the numerator starting with 7, and the following term will be 1 less than 7. And in the denominator, you'll have the factorial of 2. So you can see that in the denominator, you have 2 factorial. So 10C3, you have 3 terms in the numerator, and in the denominator, you have the factorial of 3. 15C4, you have 4 terms in the numerator starting with 15. Every following term, 1 less than 15. And in the denominator, you have 4 factorial. 5C3, 3 terms in the numerator. In the denominator, you have 3 factorial. Okay, so this is basically the approach we use when we don't have very large values, okay, where R is not very large. So what we do is we basically make a standard rule. That means NC0 is equal to 1. We saw that earlier. And we saw that NC1 is equal to n. And if it's NC2, that would be n into n minus 1 upon 2 factorial. If it's NC3, it's going to be n. And then the next term will be n minus 1. And then the term after that will be 1 less than n minus 1. So that's n minus 2 divided by 3 factorial. Okay, and the same pattern continues. So if, let's say, you wanted to work out NC4, you would do n into n minus 1 into n minus 2 into n minus 3. This way you have 4 terms in the numerator. And in the denominator, you'll have 4 factorial, whatever that is equal to. Now, if you think about it, there's a formula as well. I know you guys are probably thinking that, there's a formula that we're supposed to know. And you're right, there is a formula. Okay, and that's what we're going to learn. We're going to learn the formula as well. But I want you to make a note of one thing, that the formula is best used for large values of R. And I'm going to prove that to you. Okay, I'm going to prove that to you, that you don't always have to rely on the formula. It's best used when you have really large values of R. And what's that formula? Let's cut this question. It's annoying. And let's paste it over here for the time being. What's the formula? Here's the formula. NCR is equals to n factorial. And then you have n minus r factorial multiplied by r factorial. I hope you're aware of what factorial is. So factorial is that you start with n and then you go all the way to 1. Okay, so if it's 5 factorial, 5, 4, 3, 2, 1, all these terms multiplied, that's what it is. So notice one thing, that irrespective of whether I use the formula or whether I use the expansion that I've done above, we get the same thing. So for example, let's say we want to test out what is NC3, and let's do it with the help of the formula. So NC3 is n factorial as per the formula over n minus r factorial. That means n minus 3 factorial into 3 factorial. Okay, now you might think that, wait a minute, this and this are different. And you'd be right. They're not the same. But how is it that this can be made equal to this, or this can be made equal to this? So hold on to your seats. N factorial means n into n minus 1 into n minus 2, and we'll keep on going. It'll keep on going because we don't know what n is, so it'll just continue forever. N minus 3, n minus 4, n minus 5, n minus 6, so on and so forth. But notice that we have n minus 3 factorial in the denominator. So how about I write it as n into n minus 1 into n minus 2, and then I put a factorial after n minus 3. So it's like this. 5 factorial can also be written as 5 into 4 into 3 factorial. Okay, instead of writing 5 into 4 into 3 into 2 into 1, you can write it as 5 into 4 into 3 factorial, or even 5 into 4 factorial, or even 5 into 4 into 3 into 2 factorial. It's the same thing. Okay, so I'll do it on the side to show you what I'm talking about. So 5 factorial, we know very well, is 5 into 4 into 3 into 2 into 1. So 5 factorial can be written as 5 into 4 factorial, because 4 factorial is in fact 4 into 3 into 2 into 1. 5 factorial can also be written as 5 into 4 into 3 factorial, because 3 factorial is 3 into 2 into 1. And you get the point. Now, why have I specifically chosen n minus 3 factorial? Because that's exactly what we have in the denominator. So in the denominator, we have n minus 3 factorial times 3 factorial. So what happens as a result? N minus 3 factorial and n minus 3 factorial cancels. And notice what you're left with? You're left with n into n minus 1 into n minus 2 into 3 factorial. Does that remind you of something? I hope it does. It's exactly what the expansion of NC3 is equal to. Okay, so that's how it works. It's no rocket science. Okay, the formula and what I've done over here is no rocket science. They're all connected, and this is the connection. And feel free to work this out with NC4, NC5, and you'll notice that you get the same result. Now, the question that you guys are probably thinking of is, when do we decide that we have to use the formula? When do we decide that we don't have to use the formula? So I'll answer that question with the help of 3 example questions that I've chosen to solve. Yeah, okay, so you can see that I have just 2, whereas I was supposed to have 3. Okay, so anyway, I'll bring the third question, nothing for you guys to worry about. So these are all past paper questions. I want you guys to keep that in mind. The combinations of n objects taken 4 at a time, what does that mean? n objects taken 4 at a time, that means NC4 is equal to 6 times, that means 6 into the number of combinations of n objects taken 2 at a time. So n objects taken 2 at a time basically means NC2. So n objects taken 2 at a time means NC2. Now, should I use the formula here or should I do it directly? Well, NC4 and NC2, if you expand it using this, they're not that lengthy. Okay, so that means it's not recommended that you use the formula over here. So let's try and do it without the formula and see what happens. NC4 is basically n into n minus 1 into n minus 2 into n minus 3. So how many terms do we have? We have 4 terms in the numerator, so we stop here. In the denominator, it's 4 factorial. Now we know that we have to simplify it, so might as well start with writing what 4 factorial is actually equal to, instead of writing it as 4 factorial first and then simplifying in the next step. Equals to 6 times NC2, which means n times n minus 1, 2 terms in the numerator, divided by the factorial of 2, which is as good as 2. You might want to write it as 2 times 1, but it's as good as 2. Okay, now what happens? Now this is my favorite step. N into n minus 1 cancels with n into n minus 1. 2 into 1 cancels with 2 times 1. Anything else that you can simplify? I don't think so. So might as well start expanding and cross multiplying. N into n is n square minus 3n minus 2n plus 6 is equals to 4 times 3, that's 12. 12 times 6, 60, 72. Now let's get all the terms over to the left hand side. So we have n square minus 5n. 6 minus 72, that will be 66. Is it? Is it 66? Yeah, it's 66. I think I've done it correctly. Okay, now what do we do next? Now we solve this like we solve any other quadratic equation. So how do I solve this? You can do middle term breaking here. So n square minus 11n plus 6n, because 11 times 6 is 66, minus 66 as it is equals to 0, n into n minus 11 and 6 into n minus 11 equals to 0. Now you know very well that we will get two values over here. One will be minus 6 and the other value of n will be 11. Now obviously minus 6 is not possible because we're talking about objects over here. Even though the question does not say write the positive value of n, but we have our common sense which tells us that the value of n has got to be positive. It can't be negative because we're dealing with objects over here. So that means the correct answer is 11. And you know what? I'm going to test this out and see if the answer is actually correct or not. And to do that, I'm going to use a calculator, okay, just to be on the safe side and just to prove it to you guys that this answer is in fact correct. So that means according to the question, 11C4, okay, that's equal to 330, should be equal to 6 times 11C2, and that's correct. 330 equals to 330, that means the answer is in fact correct. Now you can check this without using your calculator, or you can check this with the calculator, it's up to you really. But anyway, the answer is correct. So n is equal to 11. Now notice we didn't really need to use the formula over here. Now I do encourage you to solve this question yourself. I'm going to give you the answer and you guys can check and see whether it's correct or not. The answer to this question is, okay, let me make sure that I give you the correct answer. So the answer to this question is okay, surprisingly I don't have the answer to this question. Okay, I do. The answer to this question is 14. Okay, so I do encourage you guys to solve this and I'll just get you started and then you can solve the rest of it yourself. So 45 times NC4. So here also, if you notice that we have NC4, so that means we don't really have to use a calculator, and then we have n plus 1 C5. So we could use a calculator or we couldn't use a calculator. But in this, if I were doing this in the exam, I would probably not use a calculator. Okay. In the following question, there's another question which I'm going to solve in which I'm definitely going to use a calculator. So 45 into NC4, that means n into n minus 1 into n minus 2 into n minus 3. Okay. So 4 terms in the numerator, divide by 4 factorial. That means 4 times 3 times 2 times 1. Okay. Is equal to n plus 1. Okay. So we have an interesting situation here. Multiplied by n plus 1 C5. So that means we'll start with n plus 1 and then we will have altogether 5 terms in the numerator starting with n plus 1, and every following term will be 1 less than n plus 1. That means the following term will be n, the following term will be n minus 1, the following term will be n minus 2, and then the term after that will be n minus 3. How many terms do we have in total? 1, 2, 3, 4, 5. That's correct. And in the denominator, we'll have 5 factorial, which is 5 into 4 into 3 into 2 into 1. Now let's begin the cancellation part, my favorite part, the most satisfying part. So n minus 1, n minus 2, n minus 3, along with n actually, cancels with n into n minus 1 into n minus 2 into n minus 3. 4 into 3 into 2 into 1 cancels with 4 into 3 into 2 into 1. Now if you think about it, we just have n plus 1 into n plus 1. So that's going to be n plus 1, the whole thing squared. And this 45 will be multiplied by this 5. So 45 times 5, that is 225. Yeah, 225. So n plus 1, the whole thing squared, is equals to 225. Don't expand n plus 1, the whole thing squared, because you can take the square root on both sides. And when you do that, you get plus minus 15. Now obviously we're going to go with the positive value. So n plus 1 equals to 15. That means n is equals to 14. So here we go. We have the correct answer, and that's 14. Okay, I just realized that I said that I'm not going to solve this question, but I just ended up solving it for you guys. But anyway, so now the question that we're going to solve is the question in which you will notice that it's best if you use a calculator. And here it is. So this is the last question that I'm going to solve. And let's see what this says. Now, how do I know by looking at this question that I have to use a calculator? I think I should do it on a fresh page because I'll probably run out of space. So how do I know that I have to use a calculator? Well, very simple. Notice that we have NC12. So if I use the same approach, meaning n into n minus 1 into n minus 2, I'll just keep on going forever. I could do it, but it's just going to take very long. And then here also we have n plus 1 C11. So it's going to take us a while if we don't use the formula. So let's use the formula. 16 times, now what's the formula? I'll write it down over here. NCR is n factorial over n minus r factorial into r factorial. Okay, so that's the formula. Now, NC12 means n factorial over n minus 12 factorial into 12 factorial, or simply 12 factorial. You don't necessarily have to write down the multiplication sign. It's understood that they're being multiplied. And then we have n minus 10 as is, multiplied by n plus 1 C1. So that means n plus 1 factorial. In the denominator, we will have n plus 1 minus 11 factorial. We'll simplify this in the next step into 11 factorial. Okay, so I'm just going to copy paste this. Okay, and everything remains the same here except that n plus 1 minus 11. Now, if you want to do this in the first step, go ahead. You're very welcome to do this in the first step also. N plus 1 minus 11 becomes n minus 10 factorial. Okay, now, what do we do? How do we simplify this? Let's see what we can do here. So notice that we have n plus 1 factorial here and we have n factorial here. So that means if I start expanding n plus 1 factorial, it would be n factorial, n plus 1, and then the following term would be 1 less than n plus 1, meaning it would be n factorial. And then after that, n minus 1, n minus 1, n minus 2, n minus 3. So n plus 1 factorial is basically equal to n plus 1 into n minus 1 into n minus 2, so on and so forth. So can I write n plus 1 factorial as n plus 1? And then the factorial, I write it with the term that comes after it. You know, just like 5 factorial can be written as 5 into 4 factorial. So here also n plus 1 can be written as n plus 1 into n factorial. Now why have I done this? Why have I done this specifically? Because we have an n factorial here, and if we have an n factorial here, we can cross out the factorial. The idea is to get rid of the factorial, because if factorial is in terms of n, we really can't expand it. So the idea is to somehow get the same factorials on both sides and to get rid of them. Okay? Now, if you look at the denominator, in the denominator we have n minus 10 factorial, which means that can be written as n minus 10 into n minus 11, okay, into n minus 12 factorial. Yeah, I think that can be done. N minus 10 into n minus 11 into n minus 12 factorial. Now, once again, why have I chosen this specifically? I've chosen this because if you look at what's going on across the equals to sign, we have n minus 12 factorial and we have n factorial. So that means we can eventually cross this out and we can eventually cross this out. And do not forget the 11 factorial, which is there from before. Okay, and don't expand 11 factorial, and I'll explain why that is. Now, if you look at the left-hand side, you have 16 into n factorial upon n minus 12 factorial into 12 factorial, which, by the way, can be written as 12 into 11 factorial. And that's it. You've done all the hard work now. Now it's time to do my favorite step, which is to start crossing things out. So n minus 10 cancels. N factorial cancels with n factorial. Remember that if you are being Add Maths student, I'm sure you guys are aware of this, but it's my job to make sure to mention it again and again. And that is, when you are simplifying a fraction, you cross out the numerator with the denominator. When you're simplifying across the equals to sign, you cross the numerator with the numerator. Okay, what's next? We can cross out the 11 factorial with 11 factorial. We can cross out the n minus 12 factorial with n minus 12 factorial. And what is it that we're left with? Okay, so we're left with 16 and 12 here, which we can also simplify using the table of 4. 4 4s are, 4 3s are. So all we're left with on the left-hand side is 4 upon 3, so might as well write that down. On the left-hand side, what we're left with is n plus 1. On the right-hand side, sorry. What we're left with is n plus 1 over n minus 11. And just making sure that I haven't made a sign error or something, or a calculation error. I think we're good. Now let's cross multiply. So you have 4n minus 44 is equals to 3n plus 3. Let's get all the n's on one side. So n is equals to 44 plus 3, which is equal to 47. And there you go. That's the answer. Okay. So I hope it's clear. I hope you've understood this. And I hope you can now solve all the questions of NCR without a calculator. In the next video, we're going to learn how to do questions of NPR without a calculator. So I'll see you guys then. Take care. Allah Hafiz.